In this video, we will cover constants, parameters, functions, and spacetime functions used in this example. This is the default simulation you will see when starting a new simulation from scratch. Here on the right, you will see all of your geometries, grids, current distributions, and other things you need in your simulation. You can rotate all these things around by right-clicking with the mouse and dragging, and you can translate everything by holding Shift and right-clicking as well. If you ever move things off screen, zoom in too far, zoom out too far, you can always reset everything by clicking Reset Position. If you ever need to hide the grid so you can see geometries or other features behind it, you can come over here to the tree, select your grid, and uncheck this box here. Constants and parameters are a crucial part of making your simulation flexible and versatile and should be used in every simulation. Both constants and parameters are used to define values that you will need to reference later. In all simulations, there are several useful constants built in, like the speed of light and pi, which can be seen by expanding the constants tree here. You can add your own constants as well by right-clicking on constants and clicking Add User Defined. Here you can rename it to whatever you need and enter a value by double-clicking here. You can remove unneeded constants by clicking on that constant and clicking Remove here. The difference between constants and parameters is that parameters can depend on constants and other parameters. For example, let's say we have a constant that represents our 5 GHz frequency. We can right-click here, click Add User Defined, rename it to frequency 5 GHz, and change its value to 5E9, like so. Next, we can add a new parameter, which is going to represent the period of the signal. Now we can right-click, Add User Defined, rename it to period, and then we can just say that our expression is 1 over our frequency of 5 GHz. As you can imagine, using things like parameters can make your simulation very versatile, as you can have many things depending on a single constant, and when you change that single constant, all other parameters in your simulation will be updated accordingly. So here I went ahead and added all of the other constants and parameters we will be using in this simulation. Some of the constants that were added include things like the grids xmin, xmax, ymin, ymax, etc. And I've also included some more parameters, things like the rise time and the length of the grid, which will become more useful later on. In a typical workflow, it's more likely that you will add these parameters and constants as you find you need them, instead of adding them all at once in the beginning like I've done here. Moving on to the functions, this simulation actually doesn't use any functions, although they work very similarly to parameters in that they can take several user-defined arguments and produce outputs as needed. Functions are just another tool helping you create a flexible simulation. This simulation does take advantage of a few spacetime functions. The key difference between spacetime functions and regular functions is that spacetime functions can only depend on space and time, meaning x, y, z, and t. In this case, we will use spacetime functions to define a simple antenna signal that varies in time. We'll have a turn-on spacetime function that is simply a function that slowly ramps up in time using a combination of min and max functions and a sine squared function. We will also use a source function, which is a simple sine function at the frequency we want to use. To create a spacetime function, we can right-click on Spacetime Functions and select Add Spacetime Function and select Expression. Here, we can rename this to be our turn-on function, and the expression will look something like this. We can also include another spacetime function called source. And the expression for source will be the following. Finally, we can multiply these two functions together to create our full antenna signal, which we can do by adding one more expression, call it turn on source, and the expression will simply be source times turn on. The result of multiplying these two functions together should result in a signal that looks like this. As you can see, there is some amount of time where the signal is slowly ramping up for the duration of rise time, and then it becomes our simple source signal after that. So that covers all of the constants, parameters, and functions that we will be using in this example. In the next video, we will discuss geometries, materials, and the grid that will be used in this example as well.